All right, guys, this is part 2 of the Saito protocol. And what I'm going to aim to do here is go more in depth into how blockchains work, how Saito works, what is Infuria, what is a node, does sharding solve the blockchain bloat problem? Like blockchains are growing exponentially. Does sharding solve that? So basically, we're going to go over a lot of stuff about a problem that's been pretty persistent in blockchain space and has not been addressed yet. And this project aims to address that problem. So what's going on here? How Saito works. So in the old blockchain system, you have this regular old blockchain with blocks being added and new ones, and you constantly were adding new ones. And so the blockchain size grew based on whatever data size is being added each and every time. So, it's like some data size, right? Like this is a data size plus the new block, which is another data size plus a new block plus a new block. That's what a blockchain is. And this right here being the entire blockchain, and this being new blocks equals the sum equals the size of the total blockchain. What Saito does is instead, like at the end of some period, what it does is it recycles the oldest block and adds it into the new. So it includes the oldest block into the newest one, and it pays some fee to have persistence, some fee that keeps it in the blockchain. So in effect, the blockchain is kind of like a loop, and that is what's going on here. It's called an epoch, and what it is the blockchain is a loop now, and so this whole blockchain could be considered the size of the data, and you could say, oh, the entire blockchain is 1 terabyte, and just keep it that size, and the completion of the cycle, the time it takes to run a whole epoch for the blockchain to start renewing could be 100 years, could be 1 year, however long you need persistence in the blockchain history. So, there's pros and cons to this. This is a different design structure, and I personally think there's once again, you're going to want a blockchain that'll last forever, like beyond 100 years, and you're going to want to have blockchains that don't last 100 years. And for every blockchain that doesn't need to have 100 years of history, you can have something like Saito or whatever. And for scalable blockchains, for if you really need scaling, the blockchain bloat can get very, like Ethereum right now is around 500 gigabytes, right? Somewhere in that range. But if we want Ethereum to really scale and go to billions to trillions of transactions, the current design of Ethereum is not feasible, okay? Because that's, orders of magnitude more than 500 gigabytes. And so Saito actually is scalable and how it does that is creates an associated cost for adding data to the blockchain. So, and the way it does that is it takes the old blocks, puts it into the new one, and it's like a rent. Each completion of the cycle, like the completion of the blockchain cycle, let's say it's 100 years, will pay rent to keep its balance on the blockchain. Whatever that fee is to rebroadcast it, to reinitialize that data back in the blockchain. So that's like blockchain rent in a sense. And it's called atomic transaction rebroadcasting. And it removes spent transaction. It clears space for new transactions and balances. And there's a fee for rebroadcasting. And it's going to be pretty cheap. It's not going to be like super expensive. So let's say I had $100 worth of Saito, or in this case, let's say Bitcoin. Let's say Bitcoin ran the way Saito does, right? So every 100 years, it would take whatever the cost is for persistence in the blockchain and deduct it automatically, doing automatic rebroadcasting. So let's say it's $1 every 100 years, right? Because let's say we choose 1 terabyte, and that terabyte, that's the size of Bitcoin, and it takes 100 years to pass, right? And this is all just to get your head around this. And of course, all these numbers will be different in a scalable blockchain that's extremely fast. The cycle time could be 1 day. The whole blockchain could be cycled in 1 day, right? And so it only has a history of 1 day, or however long you want that to be. And it could be whatever size you want it to be. So but what I'm saying here is just for the sake of getting the big picture. So let's say it's 100 years. So let's say it was $1 per 100 years. So that means you would last 100 years times 100, because it would be $1 per year. So, or per 100 years. So you would be 10,000 years that balance would exist. Of course, it wouldn't be the same balance. It would be $99 at the end of the first cycle, $98 at Bitcoin's worth of money at the end of, or let's say it's 100 Bitcoin, and just make it super easy, and it's 1 Bitcoin, right? Obviously, these are made up numbers, just so you can get the idea. So each 1 Bitcoin would be the cost. In this scenario, we're just making it super simple. And so, it would deduce that much from the balance to persist in the blockchain over at epochs. And it could be beyond lifespans, okay? So and all these things are going to be determined on Saito in the future. So that's what fees for rebroadcasting is. It's the rent per epoch. And I don't know how long their epoch is going to be, and I don't even know how much data is going to be the size of their blockchain. But now with Saito, you're actually confining the size of the blockchain. Whereas the blockchain for Bitcoin could grow forever, the size of the Bitcoin blockchain is going to grow forever. The size of the Ethereum blockchain is going to grow forever. And that's not sustainable for a scalable blockchain that wants to do 1,000 times more transactions, 10,000, 1,000,000. That's not scalable. So Saito does solve scalability by having economic ties to the cost of staying in the blockchain, for staying in the blockchain history. And that's a really profound thing, guys. And that's why I did at it, that's why I think this is a powerful project. So price reflects market costs, okay? And so the equilibrium, as much data comes in as is removed. So it will reach some equilibrium based on market factors, so that there will be some persistent size of the blockchain. And there will be no blockchain bloat, and it will have zero inflation. The blockchain will remain some constant amount of tokens. So unspent transaction outputs. What are unspent transaction outputs? And this is just a simple overview of that. So basically, it's just inputs equal outputs. An example is Bob has 5 Bitcoin, and he sends 2 to Alice, and 3 Bitcoin is returned to Bob. That's basically it. That's all that unspent transactions are. Is the change goes back to Bob, because he only sent 2 Bitcoin to Alice, so it sends 3 back to himself. It's basically account balances. And the account balance will go down per epoch to remain on the blockchain. So basically, balances pay to exist on the network. And so Bitcoin will grow to infinity, and Saito will have a confined size of the total blockchain. And so, and it'll be some data constant, which will be decided by the rules of the network. I don't know why my pen is not working, but it is having issues right now. All right. So yeah. Total size of the blockchain will be the sum of all the blocks. And so there'll be some number of blocks that exist. So Saito is finite, whereas other blockchains go on forever. With each, it'll reach an equilibrium of old data out and new data in. And only full blockchain nodes can add new blocks as they need to know the rebroadcasting data. So there will be no cheating, and the whole history will persist in Saito. Whereas Bitcoin full nodes, it's something called full nodes, are more rare because they're expensive. The same thing with Ethereum. So one of the things that they do is transaction mean pool. The source of the transaction, the application, the node, will get half. And every other nodes, the further skips away, will get half as well, decreasing by half each time. So the chance of winning, so in sense of transactions, the proof of work consensus mechanism of Saito has it to where transaction handling is proof of work. And so the amount of routing fees gathered is the amount, half of them go to the source and the other half go to the network as a whole, decreasing the further you get away from the application. So they have something called golden ticket, which is routing nodes and miners that get paid, and is a computational puzzle, requires block hash to solve, and it rewards miners and routing node, and its chance of winning is, once again, close to the work being done. And no one wins if no one wins the block, the reward is burned. And all of these mechanisms get rid of the 51% attack problem, and it's always burning money if attacked. Now, I'll go over why the 51% attack does pose a problem for Bitcoin and other networks that don't exist right now, but we'll get there in a minute. So let me go over, okay, I'll just keep going. Okay, so rewards are based on what users want and need, which is great. Forces providers to fit market demands because providing transactions equals higher chance of rewards. Users signal what services they want through the fees that they're willing to pay on the network. And so all of this equals blockchain rent. So it creates a value on Saito that must be paid to rent to justify the existence. And this happens automatically as if a balance is bigger than justification fee than the old balance. So your balance will only pay if it'll otherwise disappear if it's the size of the fee to keep its persistence for each epoch. So the new balance that you'll have is the new balance plus whatever that fee is, or minus that fee for persistence per epoch. And it'll be a market determined rate. So what this does is this solves Ethereum's Infuria problem, and a lot of blockchains have this problem. And we'll go over a section in a minute about what that is. But basically, Ethereum is centralized. It's controlled by Joe Lubin's company, Infuria. And it also solves the 51% attack. We're going to go over Infuria in a minute, but let me go over the 51% attack. So imagine that an attack to Bitcoin, you could rent 51% attack. So they say, you're not going to spend that much money to attack Bitcoin for a 51% attack. You're not going to buy the hardware. But they don't account for renting that hardware, that hash ability. And this means that Bitcoin might not persist in the future. Like Michael Saylor likes to say, Bitcoin can last 100 years. But here's a possibility where it won't. And this is, it's not possible now to rent a 51% attack. Sure, I'll give you that. There's no way that you're going to be able to rent 51% attack equipment, but the future for this is unknown. So consider a future with VR, and likely deep processing networks will arise. So is Bitcoin really future-proof? So right now, the Bitcoin hash rate is pretty large compared to anything else. There is no other network of even a comparable size. But in the future, we might have a huge VR, AR market. And this is just an example, guys. This may not come to fruition, but I'm trying to come up with an idea of the risks associated with Bitcoin. So let's say this is the size of the networks, the hash network outside of Bitcoin. And let's say you want to reverse a $1 billion transaction on Bitcoin. Well, you could rent rent some portion of this VR AR availability processing network. And if it's rented for less than the transaction you're trying to reverse, you can do a 51% attack and reverse a transaction. So this is, this may not be possible, but all you need to do is rent it for the amount of time for one transaction. For Bitcoin, it could be like 1 hour, an hour, or 2 hours, and that's it. To reverse a transaction, to fool someone and make something happen, etc. But, I don't know if this is going to happen. This is very far-fetched. I think it's a low possibility, but it still gives you an idea of, hey, is Bitcoin really future-proof? And quantum computers, etc. And Bitcoin is very bad at making decisions because it has no governance. Okay, so let's go into what is Infuria. Infuria is a software as a service platform that provides Ethereum nodes as a service. And it runs on AWS servers, so it's a centralized service. Amazon is the gateway, thus, to Ethereum. 80% of transactions go through Infuria. AWS could single-handedly shut down Ethereum apps, 80% of them, causing absolute destruction and destroy the Ethereum ecosystem. Ethereum is centralized. It's controlled by Joe Lubin, which is Infuria. Okay, and this is something no one else will tell you. Okay, so it appears that basically Infuria is just a pre-set up node, and it just helps take away API logic and library handling and setting up a node as a developer. It takes workloads off of developers, and that's why developers use it. So instead of using your own node, you go to Infuria and you use their node. It makes developers' development easier, and you don't have to set up your own node. All the work to sync, all the crash-proof stuff, all that work is completed by Infuria. It's predetermined APIs as opposed to learning your own node setup, setting up, doing the libraries, etc. for yourself. It takes a huge workload off of you. This guy, Afri Skodon, said if Ethereum doesn't stop relying on Infuria, the vision of Ethereum will have failed. So guys, don't listen to me. Listen to the Ethereum developers. This guy is a core developer on Ethereum. And he's saying if the Infuria situation doesn't go away, Ethereum is doomed. And there's no sign of Ethereum solving this anytime soon. And this guy is a pioneer of Ethereum to multi-client testnets. He's a tech support for release manager for Parity ETH client. And he's the ETH Berlin design, but most importantly, he's Ethereum core dev for EIP editor and hard fork coordinator for 2009 Istanbul hard fork. So this is an Ethereum core dev saying the vision of Ethereum is dead. And this guy has since moved on to Polkadot through Parity Technologies. So once again, I hope you guys are seeing that is Ethereum really the future when the core devs are saying that Infuria and even Joe Lubin's company basically owns Ethereum. And that company also owns all the news networks, so they control the messaging too. So they're going to put out messages that Ethereum is, never going to die because they control the media, they control the Cointelegram and all those different organizations. They've bought them, so they control the messaging as well. So I just want you guys to think about that. And I know I'm probably going to get hate for saying that as well. But once again, Ethereum is my second biggest holding. But I'm very skeptical as to what Ethereum's future is because Ethereum is not handling these things very well. Okay, so what is a node? There's two types, full node and partial nodes. Full nodes contain the entire blockchain history. They verify blocks being added. Basically, it's the full blockchain. And for Bitcoin, you need about, it's getting up to 1 terabyte, or it's going to get there. Miners are different as they do a lot of work for, but they don't store anything. Full nodes are not compensated. So guys, the reason we're talking about all this is Saito compensates full nodes. They compensate for everyone having full nodes so the history persists. And it's a low cost. It's not a big cost, but it needs to be accounted for. And that's what's causing it to bloat in other blockchains because it's not accounted for. Saito solved that. Right now in Bitcoin, it's volunteer-based. And I'm sure rich investors will, keep subsidizing it because they want persistence in Bitcoin. You got Michael Saylor, he's a multi-billionaire. He's going to pay for, for him, it's not a big issue to set up Bitcoin full nodes. And I actually don't think it's going to be an issue for something like Bitcoin. But it's not a problem for Bitcoin. But it is a problem for a scalable blockchain. A scalable blockchain needs to have the associated costs with the blockchain in there. You cannot have a scalable blockchain without the costs being associated there. A partial node can only really give you relative local data. So blockchain bloat is the size of the full history, and it will cause centralization or even entire network failure in the long run. So this is the problem with Ethereum. Ethereum is not programmed for the long run. Even Bitcoin isn't, but once again, Bitcoin's not scalable. It doesn't need to be scalable. It could just be slow and be for the rich. Okay, so Bitcoin, it's not a biggest deal because it could be hundreds of years before it's an issue. Hundreds of years, no one cares about that. That's thousands of years or 100 years down the line. But for a scalable blockchain, it is an issue. So Ethereum sharding is not a solution. I'm going to tell you why. So basically what sharding is it splits the network into subsections. So Ethereum will be split into 16 shards. So this is the Ethereum network right now. It's just a bunch of, all of these, each one of these hold the same data. But with sharding, each one would hold a different set of data. And you could see that each one of these colors would represent a different fraction of the total Ethereum network. Like each one of these sections represents a section, a subsection. So it basically increases the blockchain size 16x. So yeah, that's fine. That's adds a little scalability, but it's not a permanent solution. And as long as the blockchain outgrows Moore's law, this is not a sustainable approach. And so it's not a scalable approach. And it'll lead to system failure. So, and it equals to collusion of shard holders. There's a risk with that because each one of these shards could collude. Like, see these red? All of these nodes could get together and collude. But, I don't think that's a big issue because they randomize the additions to the shards. And so, even though there's 16 parts to the whole Ethereum network after it goes to a multi-threaded, multi-sharded system, the nodes don't know which shard they're writing to at any point in time. And you could, but what another thing with the sharding is it adds a huge layer of complexity. It makes it much more complex to get that Ethereum full node history. And it also adds ambiguity, and it just makes it the whole thing like probably 100 times more complex. And you're only getting about a 16x scale, which is not a permanent solution, guys. So what I'm trying to highlight here is Saito adds an associated cost with existing in a persistent blockchain. And that is a powerful transformative thing. Okay, and finally, you could leave here if you want, but I'm going to go over a little bit of math. So the blockchain math is based on averages. So if you have a blockchain size, the blockchain epoch will equal approximately the complete cycle time, which will equal E in our case. And the data size of a single block is D for a single block. A single block settlement time is block settlement time. These are the variables. And total cost of data storage for a single block is cost per single block. So if you have blocks per epoch, right, which will equal, times the cost of a single block, right, you'll get total cost of the blockchain cost. So blocks per epoch, however many blocks are in a total cycle, times the cost of a single block equals the blockchain value. This is the first time a project will have a set cost basis for the entire blockchain history. So the whole blockchain will be an entity, and it will have an add to blockchain data bandwidth. And so a full node operators will be paid for this service. Whereas in other blockchains, they're not, and you get blockchain bloat. This blockchain will have a blockchain bandwidth. And it could be over 100 years, it could be 24 hours, whatever. We don't know that stuff yet, but this is powerful stuff because this actually aims to solve the blockchain bloat problem by adding that cost to the structure, which is, it's amazing that we've reached this far in blockchain without this. So that's why I think Saito is a powerful project, and that's even why I'm going over it. And this is, to emphasize why Saito is so powerful, because it actually adds the blockchain history as the associated cost in addition to the bandwidth costs of other stuff, etc. So, it'll give you a value of the historical record, versus the blockchain size. If we have, blocks per epoch, and et cetera, et cetera. So that's just some of the basic math there. All right, guys, so I hope I emphasized here. The one thing I really want to emphasize here is that current blockchains are growing exponentially. And this is fine with Ethereum and Bitcoin because they're slow. But if we're going to scale this thing to 1,000x or millions of x, we need blockchain size to be a non-issue. And we need something like Saito that actually creates an associated cost. So we can actually, so Saito will, I think it's in a good position to capture market share. The only thing that they really need to figure it out is governance, which they are working on, et cetera, et cetera. But I think this is a powerful project, guys. Very unique approach, and it actually addresses all the participants in the network. And so that's why I am going over this project. All right, guys. Hopefully this helps you understand some of the intricacies of blockchain and makes you understand why Saito is a powerful project to be considered.